So ladies and gentlemen, we have a Chapter 6, Unit 6 test, 100 points. If you do better on this test than some of your other quizzes, I could go back and replace those scores. So it's a great, bless you, great opportunity to bump up your score. I have a practice test here. You're lucky. I want to do the odd ones on this video. We'll do the even ones on a different video. So on number 1, we want to get rid of the radical in the denominator, and the only way to do that is to multiply this binomial by its conjugate. The conjugate is 5 plus the square root of 2, and what you do to the bottom you must do to the top, 5 plus the square root of 2. So on the numerator it's really easy. When you multiply 5 times 7 you get 35, and then 7 times the square root of 2 is exactly that, positive 7 times the square root of 2. That's what you get up on top. Okay, so far up on top we have this answer. Now we need to work on the bottom part. So maybe I want to do this. Let me do the work on the side. So when you distribute right here, you have 5 times 5, that's 25. 5 times square root of 2 is exactly that, 5 square root of 2. And then negative 2, or negative square root of 2 times a positive 5, that's a negative 5 square root of 2. And then negative square root of 2 times positive square root of 2, that's negative square root of 4, which later becomes minus 2. Okay, so the middle terms, the positive 5 square root of 2 and the negative 5 square root of 2, those eliminate. Whenever you multiply a binomial by the conjugate, the middle values will eliminate, and you have a 25 take away. The square root of 4 is 2, so you have 25 take away 2, which is 23, and this is the denominator of your answer. Now, as you can see, 23 can't be reduced, so there's nothing to reduce. That's your final answer right there. Like if for some reason you had a 35 down here, then yeah, you could split it onto the 7 and onto the 35, so you could cancel 35 with 35, but you have this over 35 if this were a 35, but you can't really reduce anything, so that's it, you're done. Number 2, simplifying radicals. Oh no, we said odd ones, skipping that one. On this video, just odd ones. So how do we simplify radicals? We need to split up whatever root we have. If we have a third root, a fifth root, or in this case a square root, we simply split them up. Now we do have the number 3 on the outside. That's a regular number that we are multiplying by splitting the square root of 32 and the square root of x to the 5th. So the square root of 32, if you typed it into your Casio calculator, it will give you 4 square root of 2. Or if you wanted to do it by hand, you could rewrite 32, which is a non-perfect square number. You could rewrite 32 as 16 times 2. That way you could do the square root of 16 when you split it. So what you really have is the outside 3 times 4, and then you have that square root of 2 that comes down. Okay. Now, this one over here, you could do it several different ways. We've been doing power over root, so you could do that if you'd like. You could say x to the power of 5 over the root 2. So that's really x to the power of 5 halves. And 5 halves is really improper fraction, which could be rewritten as 2.5. So you could say x to the 2 and 1/2 power. And then you could use rule 1 backwards, rule 1 of exponents backwards, to split the base into 2 x's and put the power of 2 on the first one and the power of half on the second one. You can't really do anything with x to the power of half, so since it's in a radical form, let's change it back to radical form. So you will have a nice multiplication of x squared and then times the square root of x. Now that could have been done a different way also. You could have said that x to the 5th. Let me just show you an alternate way of doing that. You could have said x to the 5th is really x to the 4th times x. That way you could split the root, and the square root of x to the 4th, power over root, that'll give you x squared, and the square root of x will stay the square root of x. It's totally up to you if you want to go to rational exponents or if you want to modify the inside to split the roots to work with roots. Anyway, let's put all the nice values out in the front. So the 3 times 4, that's 12, times x squared is exactly that, 12x squared. Bless you, bless you. And the square root of 2 times the square root of x, you could just put those together as 2x inside that root. So there's your answer, 12x squared times the square root of 2x. Let's move on to number 5. Same thing on this one, number 5. You want to split up that root. This time it's a fourth root, not a square root. So as you can see, I've split the fourth root to each of the terms. And the fourth root of 81, what does that really mean? The calculator will do it for you. If you want, just type it in, fourth root of 81. But what does that really mean? It means what value times itself 4 times will give you 81. 3, right? 3 times 3 is 9, times 3 is 27. And if you haven't worked it out, 27 times 3 is 81. So this right here actually gives us a nice, beautiful answer, 3. This next one, you could think of it as x to the power 8 over the root 4. So you could actually do 8 divided by 4 and get your next term, x squared. And the last one, you can't really, well, actually you could rewrite this guy as a rational exponent. That would be y to the power of 2 over the root 4. Now, what would that do for us? You can't really divide 2 by 4, but you could reduce 2/4, and that becomes the power of 1/2. So if we have the y to the power of 1/2, going back to radical form, that would simply be the square root of y, no more fourth root. So what's your final answer? It's right here, 3x squared square root of y. Moving on to number 7. No, number 5. Wait, I got 2 5s. Sorry about that. This is a practice test. So let's jump to this one, which is also 5 and 6. I'll only do the first one. Change the radical to a rational exponent. By the way, on the actual test, you're only going to have one of them, not 2. On the actual test, you're only going to have one of them here, not 2. On the actual test, you're only going to have one of these, not all 3 of them, all right? So obviously, this practice test is really long. It's about 30 questions or close to it, at least. The actual test tomorrow is only 20. All right, so let's do at least this one right here, the odd one. The fifth root of x to the third, they want us to change the radical form to a rational exponent. So the base x, this base x is going to stay the base x, and you will put the power over the root. So you're going to put the power 3 over the root 5. So x to the 3/5 is your answer. Now, I do want to warn some of you on your answers, you guys do this, x 3/5. That's incorrect, right? Because the 3/5 is a power. You have to make some type of effort to make that 3/5 be up here on the exponent position of the x, okay? So don't put it as a huge 3/5 right next to x. That doesn't mean that 3/5 is a power. You have to put it a little bit further up. All right, so let's jump to this next one. I'll do one of these, the first one. Let's change this to a, what do they want us to do? To a radical, a rational exponent to a radical. So we said that it's always x to the rational exponent, which would be a power over a root. So what is the root? 7, and what's the power of x? 2. Done. There's your answer. Let's do the next odd one. 9 through 11. This one's a little more interesting. By the way, these are all similar questions to the last quiz that we took. A lot of you retook it and did better. That's great. Some of you, if you still want to retake it, you could. But then again, if you do better on this test, you could override that previous quiz score. Anytime you have a negative exponent, you have to grab it, move it to the other side. So the whole thing, move it to the other side. So there is no other side. You put that fraction bar, and when you move it down, there's going to be nothing left up on top. On the bottom, you will have x to the positive 7/9. The negative becomes positive. Whenever you move one thing from the numerator to the denominator, or vice versa, the exponent changes sign. So you moved it down, it changes to positive. Now, you can't leave a radical in the denominator, or you can't leave a rational exponent in the denominator. So how do I get rid of this? This is not an equation, right? This is not an equation. Right here, we need to multiply both top and bottom by a certain value. So you're going to multiply both top and bottom by x. Now, rule 1 of exponents says that if I'm multiplying two terms with the same base, I add the exponents. So the question is, what do I need here so that when I multiply both of these and when I add both of these, I no longer have a fraction? what fraction would I need here so when I add them, it's no longer a fraction? 2/9. Excellent. So I did notice that some of you would multiply or add both top and bottom by 2/9, but you're not doing that. What you're really doing is multiplying by x to the 2/9. Okay, so keep that in mind. You're multiplying by x to the 2/9. So up here, you need to multiply by x also to the 2/9. If you don't put that x there, then it's going to be wrong. Okay, so let's not make that mistake during the test tomorrow. So what do we have here? Up on top, when I multiply, x times 2/9, that's x to the 2/9. And on the bottom, when I multiply 7/9, or x times x, I add these exponents. 7/9 plus 2/9 is 9/9, which is really x to the 1, which is really just x. Now, if the instructions say write it in exponential form, I leave it like that. I'm done. What do these instructions say? Radical form. So I need a radical there. So what is the radical in this rational exponent? What's the root here? The 2 or the 9? The 9. So you're going to put that 9 right here, and it has to be in this position. If you put it out here, it's incorrect. It has to be in this little spot between, in this little groove right here of the square root symbol. And the power is 2, so it's going to be x to the second power. That's the numerator. And in the denominator, you still have x. So this is the entire answer that I need to see in the answer column for full credit. If you don't put it over x, then technically it's not right. Okay? Exact type of questions are going to be on tomorrow's test. It might be this one that's on tomorrow's test. It might be this type of one, or this one right here. But I'm not putting all three. I'm just putting one of these three. So on this one, since we're doing the odd ones, we're skipping every other one. So on this one right here, a power to a power, what do we do with powers? Multiply them, correct? So you really have the fraction 7/18 times the fraction 9/7. If it helps you, go ahead and write that out. 7/18 times 9/7. What happens with those 7s? They cancel out. What happens with the 9 and the 18? They cancel out. You have a 1 over 2. So that's your final answer, 1/2. Not final answer of the exponents when you multiply power to a power. So what do we really have here? We have the answer u to the 1/2 power. And if they did say write it in exponential form, then that would be your answer. But they say radical form on these instructions, so you'd actually have to write this as the square root of u. So here's your answer, the square root of u. Now, if you're confused with writing it and canceling things out, you don't have to do that. I mean, I think everybody could easily cancel the 7 with the 7. That's easy. And then you could just multiply the top with the top, bottom with the bottom. You're going to end up with 9/18. And 9/18, everybody should understand that it reduces down to 1/2. Okay, so you really have u to the 1/2. That's really the square root of u. Let's move on to the next odd question. Question 13. This is a radical equation. It is a third root. But technically it's a rational exponent equation. But either way, a rational exponent is a radical. So I really have the third root of 7x minus 3. So step 1 on solving any radical equation or any rational exponent equation is to isolate this, to isolate the third root, or isolate whatever has the power of 1/3. So we need to get rid of the 2 and the minus 6. What do I get rid of first? 6. Add 6 to both sides. You're going to end up with, there you go, 2 parentheses, 7x minus 3 to the 1/3 equals 6. And now we need to get rid of that 2. Again, we want to isolate it, get that 1/3 power by itself on one side. So you're dividing by 2. You will end up with 7x minus 3 in parentheses to the 1/3 power equals 3. So that is step 1 on solving any radical equation or any equation that has a rational exponent in it. Now, after that, you need to get rid of that rational exponent or that radical by applying a certain power. So if you have a third root, what kind of power are you going to use?
3.
Power of 3. What you do to one side, do to the other. Now, if this would have been a 1/2, if you have a square root, you'd use a power of 2. A 1/5, a fifth root, you use a power of 5. So whatever you have down here, that's what you're going to use. In this case, the power of 3. So the power of 3 with the third root undoes itself. Or even if you thought about exponents, power to a power multiply, 3 times 1/3 is 1. It eliminates. So you have the nice, beautiful 7x minus 3 on the left side of the equation, and 3 times 3 times 3 is 27 on the right side of the equation. And we could all solve that. We're going to add 3 to both sides. We're going to end up with 7x equals 30. And we divide by 7 on both sides. And we end up with x equals 30 divided by 7. And we're going to leave it as an improper fraction. 100% if you write it like that. Now, you're supposed to double check, plug it in, see if it actually works. If you do plug in the 30 over 7 right here, the 7s cancel. You have 30 minus 3, that's 27. The third root of 27 is 3. 2 times 3 minus 6 is 0. So you could double check in your head. You don't have to actually show your work, but I do recommend double checking because sometimes you have extraneous solutions. Moving on to the next one, 15. What do I do to isolate? Okay, minus 3 to both sides. Now, if it would have said 3 times the square root, then yeah, I would be dividing by 3, but it says 3 plus. I need to undo the addition of 3, so I'm going to be subtracting 3. And we do to one side, you do to the other, subtract 3. My new equation is the square root of 5x minus 10 is less than or equal to 5. And you get rid of a square root by applying what power? Second power, yep, power 2. So we end up with 5x minus 10 is less than or equal to 25. Thank you. What else do? I add 10, we end up with 5x is less than or equal to 35, which means if I divide by 5, final answer is x is less than or equal to 7. That's one answer, right? Now the thing with inequalities compared to equations, an inequality, talking about an area of answers, and you have to go to the inside of the radical. I should have done this. I said this was step 1, to go to the inside of the radical and make sure that this ends up being a positive value. So if you solved it the way I just did, that's great. That's one of your answers. But the other answer comes from looking at the inside of the radical and stating that that 5x minus 10 has to be greater than or equal to 0. So this is like a second problem that you're doing. It doesn't matter if you do it first or if you do it at the end. You have to get both answers. So when you add 10 to both sides, you'll end up with 5x is greater than or equal to 10. Divide by 5 on both sides, you're going to end up with x is greater than or equal to 2. So it's not an automatic thing that it'll be compound all the time. It depends on your area. That's why I say do a sketch and put your 2 right there, your 7 over there, and let's actually represent greater than or equal to 2. That'll be a solid dot at 2, greater than to the right. And if you look at the other answer, x is less than or equal to 7, solid dot at 7, less than or equal to is that way. And it is an area that's together. So what this graph is telling me is that all of my answers are going to be right here in between 2 and 7. So it'd be a great idea to plug in a number either on the inside to see if it actually works or the outside to see if it's working or not, which on the outside it should not work. On the inside it should work. So let's pick a value right here. Give me a value in here, any value. 5, okay, 5's crystal clear between 2 and 7. So if I do plug in 5 times 5 is 25. 25 take away 10 is 15, correct? Now, you could do the square root of 15 on a calculator, or you could think square root of 16 is 4, so this has to be a little bit less than 4, maybe like 3.9. Either way, 3 plus 3.9, that's definitely less than or equal to 8. So that's a true statement. So 5 does work. You verified it. So now that you've verified it, you've tested your answer, you're going to write it as a compound inequality between the value of 2 and 7. So you have 2 right there, 7 right there, x in the middle, and you put the less than or equal to's right there. The only time you wouldn't have a less than or equal to is if it didn't have an or equal to on the original. Then you would go to the appropriate one and not put it. But the inside always has to be set greater than or equal to 0 because this has to be greater than 0 or equal to 0, because if it's negative, then it would be imaginary. So that's a compound inequality right there for number 15. Let's jump to number 17. 17 is a good one. Is the radical isolated? Step 1 is to isolate your radical, right? Well, wait a minute. First of all, do you guys want to do this equation first, or inequality, where we set this to be greater than or equal to 0, or do it second? Second? All right. So let's treat the whole thing first. We want to get the radical by itself. It has a minus sign in front. So it's kind of like if I had negative x, and I don't want a negative x, I just want the regular x. If I had a negative x, what would I do to get rid of the negative? Divide by negative 1. What you do to one side, do to the other. Now, Daniel, it's important on this that you understand that you're dividing by a negative on an inequality. So what happens to this symbol? It has to flip. If you don't flip, it's going to be wrong. Okay? So now that you've divided by a negative, you will have the radical isolated, 2a plus 4. And on the other side, you have a positive 6. And now that it's isolated, you get rid of it by applying what power? Second power. What you do to one side, you do to the other. You're going to end up with 2a plus 4. No more root, no more power. It's still less than or equal to, and it is 36 now. Maybe I should have put the 36 in black. Let's continue solving. If you subtract 4 from both sides, you're going to end up with 2a is less than or equal to 32. And if you divide 2 on both sides, you're going to get a is less than or equal to 16. Should I show my work? Minus 4, divided by 2, divided by 2. Yeah, so there's your answer. X is less than or equal to 16. That's one answer. Let's go to the inside of the radical, the 2a plus 4, and let's find our second answer by rewriting that, the 2a plus 4, and stating that it has to be greater than or equal to 0, because if not, I end up with imaginary values. So let's solve that one by subtracting 4 on both sides. We're going to have 2a is greater than or equal to negative 4, correct? And then I divide by 2. That cancels. A is greater than or equal to negative 2. So we have these two answers. A is greater than or equal to negative 2, and A is less than or equal to 16. It looks like those areas are together. If I put the negative 2 right here, and greater than or equal to is to the right, 16 right here, less than or equal to is to the left. It is an area that's together. Let's just test one of these values on the inside. What would be nice to test? 0 is great. 2 times 0? 0. What's 0 plus 4? What's the square root of 4? 2. Negative 2 is what we really have. Is negative 2 greater than negative 6? Yes, it is. It's closer to the positive. It's on the right side. So this is true. We know we have the right answer there. Let's now write it as a compound inequality. It's really simple. You just put the x right here in the middle, and then you put these symbols, always opening to the right, because the greater value is going to be greater. That doesn't, you get it, I guess. So that's your compound inequality answer right there. It's not always going to be a compound inequality. You might have just one or just the other, or maybe no solution if you tested it and didn't work. Let's move on to 18 and 19. Let's find the inverse. I've been doing the first one of each one of these, so let's just do the first one here. How do I find the inverse? This is way back from the beginning of the chapter. Switch x and y. Now, notice I'm not doing anything but switching the x and the y. Yeah, the negative belonged to the x, but I'm not going to move that negative over here with the x. I'm actually just magically switching x and y. So it's going to be a negative y, and it's going to be a positive x over here. Don't move anything except for the x and the y. Just change the x and y. And then you solve for y. So let's get y that's on the right side of this equal sign. Let's get this y by itself. We're going to subtract 3. Subtract 3. You can't really do x take away 3, so let's just rewrite it. So x take away 3 equals negative y. Final step would be to divide by negative 1, divide by negative 1. And you end up with your inverse function being, I could divide each of these by negative 1. That way you change the signs. So you're going to end up with negative x plus 3. And that's kind of weird because the inverse of y equals negative x plus 3 is y equals negative x plus 3. It is the inverse. The same exact function is the inverse of itself in this case. Jumping to 20 through 22. let's do 21 since we're doing the odd ones. And they're asking us to plug in the g function into the f function, okay? So the g function, we're going to do it in green, and it's going to go into the f, which is going to be in red. So the g function is in green, and the red function is f, right? So I need to take this green one and plug it directly into the x of the red one. Okay, so since I'm plugging in the green into the red, I'm going to rewrite my red one. The f of x function reads 3x minus 2. That's what it reads. And inside those parentheses, I'm actually plugging in that green function x minus 5. I hope with the colors it's a little more clear to you of what we're doing. We're plugging in this g function into the f function. Here's the g function, here's the f. Plug it into right here, into the variable. Where x is at, put parentheses and plug it in. And then after that, it's a question of just simplifying. 3 times x is 3x. 3 times negative 5 is negative 15. You have a minus 2 at the end. Final answer is 3x minus 17. And that's how we plug in one function into another. On the other video, I'll plug in the f into the h. And not only that, on the other video, I'm going to plug in the negative 2 into the g, do the math, get an answer, and then get that answer, and then plug it into h and get another final answer on the other video. Let's flip this paper over. There's one more question to do. And this is graphing, or actually a couple more questions to do. We'll do 23 right here. Are the following two functions inverses? How do we do that? Well, we plug in one into the other and see if everything cancels out to get x. I hope we remember this from the beginning of the chapter. So let's plug in the h of x into the g of x, and then we'll go backwards. We'll plug in the g of x into the h of x. So let's do this first one where we plug in the h of x, this whole thing, into that function right there. The g of x is in red, so I'm going to rewrite the g of x function 2x minus 9. And in that parenthesis, I'm going to put in the blue h of x function, which is 1/3 x plus 3. And when we distribute 2 times 1/3, that's 2/3, but with the x, and 2 times 3, that's 6, and then minus 9 at the end, you'll have 2/3 x minus 3. Now that clearly did not all cancel out, and you didn't just get x, so you could just stop right there. These are not inverse functions. And on the other video, I'll do 24. Right now, I'm going to jump to 25, the final 2 points of the test. Yeah, it's a long test. I apologize. We need to graph this radical equation. And I hope we remember, I recommend for you to ignore h and k. I always say put a box around your function ignoring h and k. We already know that h is positive 1 and k is negative 5. You think opposite on h and take k for what it is. What does that mean? That you're going to move 1 to the right later on, and you're going to go 5 down later on. But we box in the function ignoring h and k, and then we make an xy table with that function ignoring h and k. So I need to plug in nice inputs that when I take the square root, I could actually do the square root. That way I could easily multiply by 2. So 0 is always a great input, because the square root of 0 is 0. Square root of 0 is 0, times 2 is 0. 1 is another nice number to plug in. The square root of 1 is 1. 1 times 2 is 2. What's another nice perfect square number to plug in? 4. The square root of 4 is 2. 2 times 2 is 4. And another nice one? 9. The square root of 9 is 3, and 2 times 3 is 6. So these are the coordinates of this boxed in function without the h and k. So let's plot those points. 0, 0, 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, and 9, 1, 2, 3, 4, 5, 6. Whoops, put a dot right there. Anyway, so there are my coordinates of the boxed in function, but I need to move them according to my h and k value. So I want to take every single coordinate and move them 1 to the right and 5 down. I'm going to do these in blue. 1 to the right and 1, 2, 3, 4, 5 down. Let me zoom in so I could move them all 1 to the right and 5 down. There are my coordinates. Every single one of them got shifted 1 to the right, 5 down, 1 to the right, 5 down, and so on and so on. So the blue one is our actual, or the blue dots are our actual coordinates of our actual function, including h and k. The beginning point, this important beginning point, is the coordinate hk. hk. And what is hk? Positive 1, negative 5. Thanks for telling me, nobody. Positive 1, negative 5. All right. So that beginning point is important when we answer our final question of this test, the domain and the range. The domain are dealing with your x values. So what kind of x values do we have on this graph, this radical function that begins at the location 1, negative 5? Well, since we're talking about x, you're going to use the x value of where you begin, which is 1. So x is what compared to 1? Is it less than 1 or is it greater than 1? Greater than or equal to 1, right? Because it does start at that value. And the range is simply your k value, your y value of that beginning point. The range is y. Your y values, are they above that y value of negative 5 or below that y value of negative 5? Above. So that means that it's greater than or equal to that y value of negative 5. And that's the entire test right there, guys. Entire test right there. So on the other video, I'll do the evens if you need help on that. I recommend watching it tonight on Edmodo. And you should be set for an A+ in the class. Because if you get an A+ on this test, I'll go back and change the previous quizzes to A+, and you could have an A+ so far in your entire semester right now, up to this point, because this is all we've done. Good luck.